Hi, I am Mrs. Sloan, and this is a video for my honors biology students. And this is chapter 13 for us, the lymphatic system and immunity. And in this video series, I will have 3 videos. And the first video, you're watching it right now, we're going to talk about an overview of the lymphatic system. And then I will introduce you to your innate immunity, what everyone has, what you're born with. In video 2, we are going to talk about your adaptive or your acquired immunity, and we'll talk about B and T cells in video 2. And then in video 3, we are going to talk about induced immunity and talk about both active and passive immunity and disorders we could have with our immune system. All right, so let me get going. I'm going to make myself a little bit smaller, and let me get in presentation mode. All right, so this will be part 1. And then first thing I want you to see is how extensive your lymphatic system is. Remember when we talked about in your circulatory system how you have arteries and capillaries and veins, right? And arteries go away from your heart, veins go towards, and capillaries are where all the exchange takes place. Well, right next to every single capillary in your body, you have what's called lymph capillaries. And those lymph capillaries, they have a very important job. Remember we talked about at the exchange, at the capillaries, that you're pushing fluid out at the arterial end, that plasma that has oxygen and nutrients in it. And at the venular end, you're recovering, right, CO2 and waste. Well, sometimes you push out more fluid than you recover, and it's your extensive lymphatic system who will pick up that excess tissue fluid and return it to your circulatory system. That is just one of its jobs, but that's why it's so extensive. If you look right here, let me get a pointer. If you look right here, you can see all of these are all lymphatic vessels. And look here, do you know what these are? They're labeled lymph nodes, right? And we'll be talking about their job in checking your lymph fluid. And then I need you to see up here, these right here are your left, this one on your left side, this is your right subclavian vein. That's actually part of your circulatory system. But when your lymphatic fluid, when you collect it, it needs to get returned to your circulatory system. That's where it's going to happen. So on your notes, and if you're new to my videos, down in the descriptor of this video, you will see a link to the notes my students use. They are 2 columns. Column 1 is the scaffolding of what we will talk about, and I'll help you fill in those notes. And then column 2, I encourage you to put in pictures that will help you when you're reviewing this material. So on the basics, let's go over that. Okay, I'm going to go through these 3. Let me just pull them all out magically. Okay, so the first thing, and I already mentioned this, is it absorbs excess tissue fluid at the capillaries. It absorbs excess tissue fluid at the capillaries. So collects excess tissue fluid at the capillaries. That's your first set of notes, right? Okay, number 2, it protects your body. What does it protect it with? It produces lymphocytes. Those are B and T cells, your special forces. I'll be talking about those shortly. Okay, and then the third thing it does that a lot of people don't know about is it actually collects fat from your small intestines. It collects fat at the villi, V-I-L-L-I, they're little microscopic folds at your small intestines. Now, if this excess tissue fluid doesn't get picked up and it starts to build up, okay, then what you will end up having is an edema. Okay, so you have a slight swelling here, got some cankles going on here. This is a problem. So on your notes, problem, edema, and this is an accumulation of tissue fluid causing a swelling. This is not like a blister that you could pop and drain. This is extra fluid around every single cell in this person's ankle and calf. And it can get worse, my friends. It can be this. All right, this is a real problem. Now, I think in this case, when I looked up this picture, she had worms blocking her lymph vessels right here at the top of her leg. And so this is all excess tissue fluid. It's actually breaking through some of her skin here. Okay, so that's a problem. All right, I know you love that picture, but I will move on. Okay, so the lymphatic system is in close association with your cardiovascular system. So here you can see a capillary bed. So here's the arterial is right here. And at this end, the arterial end, the hydrostatic pressure is greatest, pushing oxygen and nutrients and vitamins all out. Now, quick moment. Remember, let me review with you real quick. Remember, your blood is made out of plasma and formed elements. The formed elements are your red blood cells, your white blood cells, and your platelets, okay? The fluid portion of blood is called plasma, and plasma is mostly water, like 90 to 92% water. But what is dissolved in that plasma? Do you remember? Gases, nutrients, proteins, salts, nitrogenous waste, and vitamins and hormones. So at the arterial end of your capillary bed, the hydrostatic pressure is greatest, and it's pushing those things out so your cells can access them from the tissue fluid. But by the time you get to the venular end of the capillary bed, your hydrostatic pressure has dropped and your osmotic pressure is greater, and it's recalling. It's bringing the waste and the CO2 back into your capillary bed. Remember, more can get pushed out than recalled, so that excess right there, it gets brought into your lymphatic capillaries, and as soon as it's in there, it's called lymph, okay? It's called lymph. So let me make myself smaller again, and let's see how that goes down, all right? So when you have these extensive lymphatic vessels all over your body, okay, so the lymph capillaries, and on your notes, close vessels are in close association with the cardiovascular system, and your lymph capillaries will drain into your lymph venules, and then these drain into lymph veins, just like your circulatory system. These lymphatic veins also have valves to keep the fluid moving in one direction. Okay, and then ultimately dumped off, it's not in this picture, but I showed it to you earlier, the subclavian veins. Okay, subclavian veins. How does it move in the lymph veins? Same as your circulatory system. They get compressed by skeletal muscles, and when they get compressed, the fluid has to move, and it can only move in one direction due to the valves. And this fluid in your lymphatic vessels, it's not called tissue fluid anymore. It's not called plasma, right? It's called lymph when it's in your lymphatic system. So once the fluid enters the lymphatic vessels, called lymph. And I think you got the one above, movement dependent upon skeletal muscle contractions. All right, so now let's break down the parts, okay, of our lymphatic system. So first thing on here, on your primary organs, are things like your red bone marrow. I'll be talking about that in just a minute, and your thymus gland, not shown in this picture. The secondary ones, the reason why I like this picture, okay, is you can see all in green. That's not circulatory system. Those are all the lymphatic vessels. And they will ultimately all drain into the subclavian vein so that your blood volume remains constant. Now, your thymus would be right above your heart, and your bone marrow is in your bone. The secondary lymph organs are tonsils, that would be in your throat, okay? And then you have lymph nodes in several different parts here in your body. Predominantly, like if you're feeling sick, you're like, feel right here, your doctor feels right there, and if it's swollen, that means you've got something going on right there. You got some foreign invaders and your body's fighting it. You also have some in your armpits and some in your groin region. And then your spleen, it's next to your stomach, kind of on the edge of your left side, okay? That is also a secondary lymphatic organ. So let's break it down more specifically. Now, sadly, we have little eviscerated girl here. And the reason why they're showing a child in this picture and not an adult is because the thymus gland is larger when you're a baby and young, and it gets smaller and smaller over time. Okay, so that's why they're showing a girl now, or a small child. Now, your special forces cells that you have, I'll be introducing those to you in a little bit. They're called B and T lymphocytes. These are like your Navy SEALs of your immune system. Both the B and T cells form from your bone marrow, as do all of your blood cells. But the B cells mature in your bone marrow, whereas T cells mature in your thymus gland. It's right here. Okay, here you can see some lymph nodes. She has them here, she has them here, she has them in her throat. Her tonsils are part of it, and then her spleen. It's over here on the left side next to her stomach, but I'll show you a close-up of that as well. Okay, so your red bone marrow is where all your blood cells come from. Red blood cells, all your white blood cells, and your platelets. So red bone marrow, all blood cells form from this tissue. okay? And then you need to put that B cells actually mature in the bone marrow. They mature in the bone marrow, okay? Whereas your thymus gland, which sits right over your heart, you can see here's the heart, here's your thymus gland. You would see it larger in young children because they're still maturing their T cells, right? Their T cells are born in the bone marrow, but they migrate to the thymus gland in order to mature. So thymus gland, T cells mature here. That's why they're called T cells. And that's why B cells are called B cells, because they mature in the bone marrow. All right. And then your spleen, okay? This is a secondary organ of your lymphatic system. And this I actually got from a cooking website because apparently some people like to eat spleen, just not me. Okay. But your spleen is over here on your left side next to your stomach. And what it does is it's always monitoring your blood. Your blood moves through your spleen and it's monitoring it for any kinds of infection. So your spleen filters your blood and monitors it, your blood. Whereas your lymph nodes, what they're monitoring is what the lymphatic vessels are picking up from around your tissues. So they're monitoring the lymph or the tissue fluid because it will not get returned in the left and right subclavian vein, okay, until it passes through a lymph node, like a checkpoint to go, okay, is there anything bad out there? So think about that, right? If you have a lymph node right at the top of your leg, then all the fluid in your leg is getting checked in one point. It's kind of like a border crossing, right? So you don't have to monitor your whole leg. You only have to monitor where that fluid from the tissue fluid from your leg is passing through, right? That's easier to monitor, right? So lymph nodes filter and monitor tissue fluid, filter and monitor your tissue fluid. Okay, and then tonsils, this person's not feeling well. Tonsils right here trap germs in your throat, trap germs in your throat. Okay, now innate immunity. Okay, so now we're moving on to the big ticket item for today. Now we know all the structures, okay? Innate immunity is what you and I are born with, this immunity. Everyone is born with it. And you know what? It does a great job. But it is not a special forces, Navy SEAL, Army Ranger kind of a fighter, okay? It is a policeman, and policemen are wonderful, okay? And we're very thankful for them. But they don't have the special training to completely eliminate something. When they see something as being foreign from yours, they'll be like, oh my gosh, there's a bad guy over there, and they'll just throw a bomb. They'll destroy the bad guy, but any of our neighboring cells as well. Your innate immunity is what develops your inflammatory response. Like if you've ever had an infection and it's swollen and it's painful, that's an inflammatory response that comes from your innate immunity. And I'm going to walk you through that. Okay. Now, the first thing you would like to do is like not to have an invader in your body, right? To keep things out of your body. So let's address those first. So the skin and body secretions, chemicals from your body can act as barriers where pathogens might want to enter. So you want your skin to be intact, right? If you get a cut in your skin, what do? You clean it with an antiseptic, maybe some hydrogen peroxide, or put some Neosporin on it, because now your body has been opened due to that cut and bacteria could get in that way. So we want to keep our skin intact. Now, so one thing that makes our skin flexible are oil glands secreting oil, which can also protect us and keep our skin soft, but can also cause acne, right? If they block some of the pores that we have as well. Now, on your notes, barriers to entry, skin and hair, skin and hair. And then oil glands inhibit the growth of bacteria. Okay. You have within your respiratory tract, okay, like your trachea, okay, you have, here are some hairs in the nose and apparently something else. But when you breathe in through your nose or through your mouth, in your respiratory tract, you have ciliated cells that are working to try to keep things up and out of your respiratory system if at possible. So you have that in your notes. Your stomach has a very, very low pH. It's very acidic and it's hoping to kill off any bacteria. So stomach with low bacteria. And then you have low pH to kill off bacteria. But you also have good bacteria that live in your body and take up real estate in your body, like in your urethra or vagina or your intestines. And they're living there so bad guys can't live there. Bad bacteria can't. So harmless bacteria living in our intestines and vagina, urethra, prevent pathogens from colonizing. And that's why if you're taking an antibiotic to get rid of a bad bacterium, a bacterial infection, it's important once you finish your antibiotic to completion that you eat things like yogurt to start developing those good cultures of bacteria again in your body. All right. So let's say it gets through the barriers. You got a cut in your skin, and so this pathogen gets in. How do we know who the invaders are? Well, every single cell and every single virus has surface markers. These surface markers identify not only the organism that it's coming from, but within us, they even identify us as individuals or what organ inside of our body it's coming from. Now, antigens are anything that will stimulate an immune response. Hopefully your own cells don't stimulate an immune response. Like rheumatoid arthritis is where somebody attacks their own joints of, let's say, their hand, okay? And that's called an autoimmune disease when you attack yourself, when you think it is an antigen, right? So we only want to attack foreign antigens, like if you had a bacterial infection or a viral infection, okay, or a splinter, even a splinter. Okay, what happens is that you then call in your armies, right? You call in your policemen in order to fight that infection off. So on your inflammatory reaction, okay, which we're working towards, this is a result of damaged tissues or invaders with surface antigens, So I'm just going to mention that damaged tissues, right? If you got a really bad ankle sprain, there's not a foreign invader in your body, but you have damaged tissues, and this can trigger an inflammatory response, right? That's why you would ice it to try to decrease that inflammatory response. So let's talk about who are the players in this, all right? Now, over here on the right, we're going to learn about this in video 2, adaptive immunity. This is a slower response, but it wipes them all out. And those are your special forces, your B cells and your T cells, okay? So put a pin in that. In fact, I'm going to just cover them up, okay? We're going to talk about these guys over here, okay? All of these guys play a role in your innate immunity. Your innate immunity. You have things that eat. Literally all of these guys, except the natural killer cell, all of these guys on here will eat anything foreign. They're like, you are not an antigen that belongs to me. I will eat you. Now, ones that are really good at eating are macrophages because they get really, really big and they can eat a lot. In fact, they will eat to their own death. And when they have done that and fought the good fight for you, when they're dead, that is what you know as pus. Pus is dead white blood cells who are fighting to protect you. Okay. Now, these three right here are all known as granulocytes, but I want to point out this neutrophil right here. He's first on the scene and he is most numerous. So let's look at our notes for a minute and look at our fighters. And the first one on there are neutrophils. And we're going to write most numerous. They are first on the scene because there's so many of them. It's like 70% of your white blood cells are neutrophils. They are first on the scene and they are eaters. Okay. Macrophages, these are even bigger eaters. They get there a little bit slowly, but they can eat even more and last longer. So macrophages are bigger eaters. And also, they pull the alarm. They release cytokines. We'll be learning about that, which says, hey, we got an infection over here. Everybody come fight. All right. Then you have dendritic cells. They are also fighters. Okay. They will eat. Okay, but they kind of clean up the battle after you're having a fight, waging war, okay, with all your soldiers here trying to protect your body. And they, like macrophages, when they kill something, it's like they cut off the head and they display it. And they're like, look what I killed. And they play a very important role, these two, in getting your adaptive immunity to be triggered, to getting your special forces to come to the scene. And I'll be talking about that in video 2. All right. Next, these natural killer cells, what do you think they do? They kill. Okay, they kill other cells. I'll talk to you a little bit more about them later. And mast cells, what they do, also part of your innate immunity, is they release histamine. And what histamine does is it makes your capillaries leaky, and it makes it so all these fighters can more easily get out of a capillary bed and get to the scene of that infection out in your tissue. So some of you have allergies where you're allergic, let's say, to pollen, right? And so what do you take when you have those allergies? It's when your body says, oh my gosh, plant sperm, it's horrible, I better fight it, okay? It's a harmless antigen, but your body fights it. So what do you take? Antihistamines to try to calm your inflammatory response down and try to combat the histamines that your mast cells are secreting, all right? Because what happens here, let me get you over here, okay? You can get an inflammation, okay? An inflammation, if you're just having allergies, you could have a runny nose or a headache because your tissues are swelling. This individual has a sty in his eye. I made this picture of inflammation, isn't it fun? This person has an infection here in their toes. This person, I read about him, he was walking through a waterway and fell backwards and sliced his hand open on some glass. That was pollution, right? Pick up your stuff. This person got a bite or a sting and they have swelling. Maybe you're one of those people. I am. When I get a mosquito bite, my body's like, oh my gosh, and I get a huge swollen mosquito bite, okay? Because my body says this shouldn't belong here. Okay, so this is an inflammatory response. Let's see how this goes down. Let's review our players again, all right? So the granulocytes, those were the basophils and the eosinophils and the neutrophils. Those are the ones I had you know on your notes. Most numerous, come to the scene and they will eat until they die. And again, they become part of pus once they have died. Okay, now the next one, the macrophages. These are the great big eaters. They're slower to the scene, but they're going to eat a lot. And they are also what's called antigen presenting cells. And they say, hey, I'm looking for a B, I'm looking for a T cell who can fight this thing. And I'll talk to you about that in video too. All right. And then you have dendritic cells. These are, again, eaters, but at a waging war, they're kind of cleaning up the dead, and they are also displaying like macrophages, antigen presenting cells, and they present on what's called MHC2s, and they're saying, hey, look what we're fighting, who can help us, all right? So when let's say you fall and you skin your knee, okay, and I'll give you details on this. You'll have a screenshot you can get on the next slide. Okay. Let's say you fall and you skin your knee. So your skin is broken. So now the invaders can get in. These are the bacteria. You have a wound. You could be bleeding. So this is going to draw the platelets in to try to clot this up, right? Here, most numerous and on the scene is a neutrophil. Now, do you see how he's squeezing out? He can squeeze out because this mast cell is secreting histamine, which makes your blood vessels a little bit leaky. All right, so he's going to come here and eat. Here's a macrophage. He is eating, and he is also releasing cytokines saying, hey, it's like pulling the fire alarm. We have an infection over here. Everybody come to the scene and start fighting it. Okay, this is a good picture for, let me get out of the way for you. Sorry. Here we go. So this has what I just said written in words. So if you want to screenshot this and put this in your notes, this would probably be a good thing. Pause, and I'm going to go. I want to talk to you about these mast cells, okay, and what they do. All right. So this is a normal capillary made out of endothelium. The spaces are pretty small. Hydrostatic pressure, forces fluids out, right? And now it's gone from being plasma to tissue fluid. Okay. This small amount of fluid, if there's too much out there, right? Remember, your lymphatic system is going to pick it up, your lymph capillaries, and it'll get returned to your circulatory system in your left and right subclavian vein after it has passed through lymph node. Now, if you have an infection, okay, the mast cells will start to secrete histamine, and look at the difference in this space. It's much bigger. And this makes it easier for a monocyte who's going to grow up to be a great big macrophage to get out there and into wherever the infection is. So what does this cause? So symptoms and causes: swelling. You get swelling because not only can the monocyte, that's going to be a macrophage, get out, but even more of your plasma can get out. So swelling. Mast cells release histamines, which cause, this is called vasodilation. As a result of this, it can get red. Okay, and it can have a higher temperature because of all of those enlarged capillaries. And that localized temperature, like if you have an infection and it feels warm, that can be good because it's fighting off the bacteria at that higher temperature. But due to all that fluid being out, it can push against nerve endings and it can cause pain as well. So the swollen area can trigger free nerve endings. The result, a fever, which inhibits growth of microorganisms, pus, which is dead phagocytic white blood cells, and these leaky dilated capillaries allows fighting cells, dendrites, neutrophils, and other white blood cells to more easily access the injury site, All right. Some more parts of your innate immune response are what's called complement proteins. These are not cells. These are like 40 plus proteins that will work together to literally drill holes in bacterial cell walls so that now they don't have a nice barrier. Water can rush in and just blow them up. Okay, so that's one thing they can do. So complement proteins or protective proteins underneath that is complement proteins can amplify the response and drill holes into bacterial cell walls. And other protective proteins too can kind of amp up your entire immune response. And so we'll look at these can cause lysis, right? If they drill holes, they will help phagocytes to eat more, like macrophages and dendritic cells. They help activate your entire inflammatory response and release of histamine. And then also they'll work with antibodies to increase phagocytosis. So they have chemical communication to warn of invaders and motivate killing. All right. And then natural killer cells. That's exactly what they do. They literally dock with one of our own body cells that is infected or has become cancerous, and they kill it. Kind of like how a lysosome digests something. They will just kind of release a little bomb inside of here and wipe them out. Okay. So on natural killer cells, they kill virus-infected cells and tumor cells. They are not specific. They have no memory. And they release protective proteins that will also stimulate your B and T cells. Those are your special forces. All right. So now I want to review again, and hopefully all of this makes sense now that we've gone over it. Look right here. Here's a mast cell. See, it's releasing histamine. Now, what will trigger it is we're going to learn about antibodies docking with mast cells, and when they're bound to an antigen, then the histamine is released. Here's a macrophage, right? It's going to eat. Natural killer cells kill. Dendritic cells eat. And dendritic cells and macrophages are antigen presenting cells. And what they're going to do is present to T cells specifically. Neutrophils neutralize, most numerous on the scene, okay? And they're going to be eating as well. So do eosinophils and basophils. All right, so that is the end of our innate immunity. And in video 2, I will talk about your adaptive or your acquired immunity. And if you're one of my students, I'll see you in class.